Hi Chem 1 students. We're going to be doing problem 5.48 today, and it says we're going to collect hydrogen gas over water at 18 degrees Celsius and a certain pressure, and this happens because lithium reacts with water. Keyword here is reacts. That is very important right there. So we're going to have a reaction. We can write this out as lithium plus water yields lithium hydroxide. Told us that lithium hydroxide was produced and then hydrogen gas. I'm going to run through this hopefully pretty quick. Pause it whenever you want to. Lithium, if we balance this out, we're going to have 2 lithium on this side, 2 here, and then 1 mole of hydrogen per 2 moles of lithium. And then what it's asking for is the volume of H2 collected. And we have it collected over water. This is very important. That means we're collecting water vapor as well as hydrogen gas. So we're going to have to subtract the water vapor from our total. It gave us the total pressure, which is 725 millimeters of mercury. And this happens to be the partial pressure of H2 plus the partial pressure of water. So what we're going to have to do is subtract partial pressure of water from the total pressure. So we have pressure of H2 equals 725 millimeters of mercury minus, we get this value of vapor pressure at 18 degrees Celsius from a table. It's table 5.2 on page 164, and that gives us 15.5 millimeters of mercury. And that's your vapor for water. Subtract that and you get 709.5 millimeters of mercury of hydrogen. So now we have pressure of hydrogen, temperature, and some grams of lithium. Now to relate temperature and pressure and moles, we have our handy P-Nerd equation, which is PV equals nRT. So we have R, we have temperature, we have our pressure. Now we want moles of H2. To find that, we have lithium here, we have grams of lithium, and we have our reaction. So we can convert the grams of lithium to H2. So to do that, we're going to take, say, our moles of hydrogen gas is going to be 0.84 grams of lithium. This was given in the equation. Now to convert that to moles of lithium, we're going to do the inverse of the molecular mass, which is 1 over 6.941 grams. And that will give us moles of lithium. Now to convert from moles of lithium to moles of hydrogen, we're going to have 1 mole of H2 per 2 moles of lithium reacted. 2 moles of lithium, 1 mole of H2, and then some moles of lithium crosses out, and we're left with moles of H2, which is going to be 0.06051 moles of H2. Now we've got moles to add to our equation, and we want volume. So we're going to pull volume to the side. So volume of H2, so we've already taken water, we've taken care of the water that was collected. So we're going to have moles times our gas constant, all times temperature all over the pressure. And our gas constant is going to be 0.0821 liters times atmospheres over Kelvin times mole. This is not to be confused with the other R value, which is 8.314 joules per mole Kelvin. This has to do with energy. We don't want that right now. We use that for one of the other chapters. We want this. This is for ideal gases, or for gases, period. But this is our ideal gas equation. So we're going to plug in all of our values, which is 0.06051 moles over pressure, which is 709.5 millimeters of mercury times our gas constant, which is 0.0821 liters times atmosphere over kelvins times moles. And that is times temperature, which is 18 degrees Celsius. Now, don't forget to convert your temperature to Kelvin. So we're going to add 273 to the temperature before it's multiplied over here. So that's going to be Kelvin. So we're going to see that all of our units cancel. But we have here, this right here, is in millimeters of mercury. So to convert that, we have 1 atmosphere per 760 millimeters of hydrogen, or mercury. That's a good conversion to remember as a chemistry student. And then all of this going to cancel out until we get liters. And this is going to be 1.54 liters of H2 by itself, without water involved.
Is that it?
Yeah.
Yeah.
Yeah, these are so much fun.